Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. We're going to go ahead and get started with lesson 1.1, but this is actually the beginning of the first unit. And in this unit, we're going to be taking a look at multiple regression. And so as you can see on the screen, this particular unit is divided into 6 parts. We're going to start with the overview of regression, as I already mentioned. We're going to take a look at how to prepare data. We're going to do 2 lessons on dealing with normality when it comes to regression. Then we're going to deal with collinearity, and lastly, we're going to look at the results of the model. So why don't we go ahead and get started by taking a look at an overview of regression. So here we go. Now, the thing is, when you're dealing with regression, you are trying to figure out the dependency of one variable on another. So if I had to give you an example, you have your y here, and you want to see x. You want to see how it relates with y, and of course you can have more than one x variable. You can have x1, x2, etc. Whatever you want. But what you're trying to figure out here is you're trying to use how x changes to see if it correlates with how y changes. That's what you're trying to look at here. And when you have simple regression, what you really have is you don't have more than one variable. You only have the one independent variable. That's kind of what's happening. And you're trying to see how they move together, because if you understand how x moves, you can make inferences about how y will move. In other words, you can explain what y is doing, and or you can predict what y will do in the future. That is kind of our primary goal. Now, here, I hope you can see these little dots here. This is a graph. This line in the middle right here is the mean. We plotted the mean here. And as you can see, the problem with the mean here is that it does not change as x changes. So what we want to do when we draw a regression line, if you will, we're trying to graph the change of x. We're trying to graph the relationship between how x changes and how y changes. That's what we're trying to do here. And so the baseline model, often in statistics, is the mean. But because it does not change as the x changes, it's not the best model. And what regression does is it is an improvement on using the mean to predict future values, because the mean is always the same. However, as x changes, we want to know how y will change correspondingly. So I hope you can see those dots here. The dots here represent the regression line that might be drawn with this data. So what's happening now is that you can clearly predict that as x increases, y increases. So when x is 4, you can clearly see that y is 4. When x is 6, you can clearly see that y is 6. So they're moving in perfect unison. So if I were to continue my line all the way up here and look at values like 9, 10, 11, and 12, I already know what they're going to be. If x is 9, say down here, I'm pretty sure y will be 9 up here. That's the beauty of regression. By using this line that minimizes the error between the data points, you're able to do that. So let me back up for a second. What was happening when we did the mean as a line is that we had all this space right here called error. These were things that we could not explain. Error. All this was happening right here. All this was happening when we were using the mean, this horizontal line. But by using this line that has a slope to it, we were able to reduce this error to 0, because all the dots are going right through the dotted line that we drew. And so that is the power of regression. By removing this error or these residuals, we are able to improve our prediction of future values and or to explain how y changes. That's what we're doing here. So I already explained to you, these are the 2 primary goals right here of regression. It is to either explain relationship between 2 or more variables or to predict future values. That's what we want. In machine learning and data science, often we're much more obsessed with predicting future values than we are about explaining relationships. However, it may depend on your particular purpose. Now, let me explain some more, and I want to repeat myself because I want to make sure this is clear. When you draw the regression line, you are reducing the error that is captured by only drawing the horizontal line for the mean. As you can already see, all the dots are going right through the line, which means that this line is essentially perfect. Everything is completely explained in this particular example. Now, this line that we drew is an example of the slope. Because see, there's two pieces of information that you have to calculate when you are making a regression. You have to calculate the slope or the steepness of the line. Another word for slope is gradient, by the way. And you also have to calculate the y-intercept. When you're able to do these two things, that is when you're able to draw your regression line. And again, if you've taken basic algebra, you're familiar with, calculating the slope, rise over run, this little thing like that. You should have learned that in high school. And so these tools are being applied now, not just for, a mental exercise as is commonly used in high school, but for practical applications in the real world. So here's the equation right here. And you can see that B1 represents the slope of the regression line and B0 represents the y-intercept. Those are the two pieces of information. Now, we're working on this on a theoretical level. But as we go forward throughout the videos, we're going to see how this is practically done inside R as we progress. Okay, now another piece of information that is very important is the R-square. It's a measure of how well the line fits the data. In many ways, the R-square is how much better this regression line you draw, how much better it is than just drawing the mean line. So the R-square can go anywhere from 0 to a value of +1. That's it, between those two ranges. And I can explain to you how it's the sum of the errors over the total sum of squares of error, whatever, and all those things like that. But the point that you need to know right now is that the higher the R-square, the better your regression line is doing at explaining the behavior of your y variable, explaining it. That's what we're trying to do here, explaining it. And also, what's connected with that is that normally as your R-square improves, as it goes from 0 all the way up to 1, your ability to predict future values will also improve. That's what you need to remember with that as well. Now, we don't just have simple regression. We have, as you can see right here, multiple regression. And that's where you have more than one independent variable. So I kind of drew this earlier. So you have your y, and then you have your x1 plus x2. As soon as you get to x2, you're in multiple regression. And so as you add more and more variables to the model, normally what happens is that you are better able to predict and or explain the behavior of the y variable. That's what I mean. And what I mean by behavior, I know maybe I'm being unclear here, is that we're trying to explain the variance, the dispersion of the data inside the y in the y variable. Because what I mean by dispersion is like, if one particular y value is high, what is the x value doing? If one particular y value is low, what is the x variables doing? Because as you're able to explain that variance, that dispersion from the mean, you are able to understand what is happening with that particular variable. Now, here's a very, very simple example here. So I'm trying to figure out here how shoe size affects height. So normally, as a person's foot gets bigger, their height gets bigger. This is an example of simple regression. Simple. Not a whole lot happening here. Okay, but here's the thing. If you were to run this model, you would get a very, very high R-square. You'd be very easy to predict future values because shoe size and height are so strongly correlated. But what's happening here is that there's something else going on. And if you look at the next slide, you can see here that you have shoe size and age. As people get older, their shoe size increases normally. As people get older, their height increases as well normally. And so what's happened is that with multiple regression, you are better able to explain and to understand what is happening in your dependent variable, because normally more variables, more witnesses. More witnesses, stronger testimony. Stronger testimony, you're better able to figure out what is happening. Every variable that you add to your model, now this is a simplistic example, every variable that you add to your model should help to improve the prediction and or the relationship that is happening within your model. So what is basically happening with regression is that as you add more and more variables, you are basically dealing with this common area. You're able to exclude it. So let's say, for example, this is my x variable, and this is my, my other x1 variable, x2 variable. As you add more variables, you're able to capture more of the variance that is only explained by those unique variables. You're able to exclude what they have in common. That's the beauty of multiple regression. You exclude what each variable is commonly explaining for the y variable, and you're able to focus more on the unique contribution of each new variable that comes into the model. Again, there are limitations on this, but this is a simple overview of what's happening. Now, one common problem with multiple regression is that every variable, as you can see here, is a dimension. And once you get beyond 2 dimensions, it gets pretty difficult to start seeing things. So you cannot graph multiple regression results, as they are. You have to make some small adjustments in order to do that. And I'm going to show you how that works. But first, you can see right here, this is a graph taken straight from R, from the dataset iris, where I'm trying to use petal width to explain the sepal dot length. And you can see here I have this nice little line here. Again, if I were to take the mean, it would be probably something like this. And you can see that's really a mess. But by drawing this slope here, this beautiful, beautiful slope, I'm able to better explain what is happening with sepal dot length. All right, but again, this is 2 dimensions. I have petal dot width is my 1 dimension, and I have sepal dot length is my 2nd dimension. Now, the beauty of regression is that what you do, instead of just focusing on these two dimensions here, when you have multiple, you take fitted values or predicted values, if you will, with the actual y values results. And so you can see here now in this model, I have several variables. I call the model flowers 2. I have several variables, and you can see right here that the distance that the dots are from the line is slightly reduced because I have more variables in my model. And again, as we go through these chapters, you're going to see this over and over again, how as you put more variables in the model, the distance or the error of each data point tends to shrink down, and they get closer and closer to the line. The line becomes better and better fitting the data. And that's what happens here. So you can see here that the distance is a little bit smaller compared to when you only have the 1 variable here. And so what's happening, again, just to make sure this is clear, I am taking the fitted values or the predicted values that my model made, and I'm comparing them to the actual values. I'm checking out this correlation here. And so I'm able to reduce all of my independent variables down here, which is several x's, if you will. I'm able to reduce those down to just 1 dimension and compare them to the y values again. Okay, because if you look closely, you can see that it's sepal dot length. That's what's happening. So that pretty much wraps up our first lesson. So what we're going to do next is that we're going to move on to Unit 2, or not Unit 2, but Lesson 1, Unit 2 in the next video. So my name is Darren Thomas. I'm the Director of Educational Research Techniques. Thank you. Take care.